Here's problem 811. A 0.04 kilogram ball is thrown from the top of a 30-meter tall building, point A, at an unknown angle above the horizontal. As shown in the figure, the ball attains a maximum height of 10 meters above the top of the building before striking the ground at point B. If air resistance is negligible, what is the value of the kinetic energy of the ball at B minus the kinetic energy of the ball at A? In other words, what is K at B minus K at A? Alright, they've already set it up kind of nicely. They've given you point A and point B. And as the energy goes, if there's no work done along the way, it doesn't really matter how you got from A to B, because mechanical energy will be conserved. So if we start with our one equation to rule them all, the kinetic energy at A plus potential energy at A plus any work done along the way equals kinetic energy at B plus potential energy at B, and we can try to evaluate this equation. Now in this case there is no air friction, and the work done by gravity is accounted for by potential energy, so we don't have to worry about that as being the work of external force. So there is no other external force to worry about, and hence the work along the way in this case is going to be zero. We do have a kinetic energy at A and we do have a kinetic energy at B, so we can keep those in this equation. But we can define our zero height at point B, the ground level, to be zero. So that would make the gravitational potential energy at B zero. We don't have any spring forces to worry about, so that looks to be what we want. And so hence we have that the kinetic energy at A plus potential energy at A, which is simply going to be mgh, h being our height above point B, this height, which is 30 meters, plus the work done along the way, which is zero, is equal to our kinetic energy at B. Looking at this, subtracting the kinetic energy at A from both sides, I have that the kinetic energy at B minus the kinetic energy at A is equal to mgh. As simple as that. If I put in the numbers here, we have the mass, which is 0.04 kilograms. We have G, which is 9.8, and we have H, which is 30 meters. So this is a energy of 0.04 times 9.8 times 30, 11.76, we'll say 11.8 joules. So the difference in kinetic energy between B and A is 11.8 joules. It's simply equal to the energy of this height, 30 meters. It doesn't really matter that we went up 10 meters and came down, because our path didn't matter. We only are concerned with our final and our initial positions, the energy present at those two positions, and this is the beauty of this energy method, that we don't have to worry about the path along the way. So that's our answer, 11.8 joules.